Hi, I'm Gabriel. I'm here with Ben, and he's going to help me with this problem. What are we working on today?
Today we're going to find where a function is increasing and decreasing, as well as where it's concave up, concave down, and the points of inflection.
Okay, perfect. So that means that we need to take the first derivative of this function, which would be f prime of x is equal to 8x to the third minus 64. And we need to find the critical numbers. To do that, we need to set this equal to 0. Is that right?
Mm-hmm. That's right.
Now, I like to stop here, especially when you have something that is really funky here. And if you notice, this is a 3, right? And what can we do when we have a 3 here? What type of equation is that?
It looks like we have a difference of cubes.
Okay.
So we have to use our formula. Well, actually, if it's a difference of cubes and we're all trying to find is the critical numbers, we can start by moving the number over the 64 and then start solving for x.
Perfect. So we would first add 64 plus 64. Those would cancel. We would be left with 8x cubed is equal to 64. And then, do we divide by 8?
We divide by 8.
Yes, right. Those 8's cancel. And now we're stuck here. 64 goes into 8.
8 times.
8 times. And then, what would we do here?
In order to get rid of the cube, we have to take the cube root.
Take the cube root. That 3 would cancel that cube root, and we would get x is equal to 2. And that is, ladies and gentlemen, our critical number. What do we do with that?
For the critical number, we have to plot it on a number line and find test points on either side of it.
Cool. And what color should our number line be?
We can do it in yellow.
Alright. So, let's say the number line starts from here and it goes this way. So that infinity is over here and negative infinity is over here. So in this case, we only have one critical number in our first derivative. So that is possible. We're just going to have one critical number. So that means that we're just going to have 2 test points. And well, I think 0 and 3 would be good numbers. What do you think?
Sounds good to me.
Now to check to see whether it's increasing from negative infinity to 2, we need to get our test points and plug them into where?
Our first derivative.
And what color is that going to be in?
If we're dealing with, well, I guess we can keep it in orange since we're on the test points.
So this is we're going to have f prime of some number here, which is going to be in orange. 8 times our test point minus 64. And we're going to do that twice, right? First, once for our first test point and the other for our second test point. And our test point's already in orange. So this is going to be 0, this is going to be 0, this is 0, I'm sorry. I lied. This is going to be 3. And this is going to be 3. So what do you get? Use your handy dandy calculator and let us know what the evaluation of this is.
Okay, for the first one, when we plug in 0, the first term is going to cancel because anything times 0 is just 0. So we get a negative 64 for the first one.
Negative 64. And so this is going to be 3 cubed. Let's see if we can beat Ben. Come on. 3 cubed, what is that? He beat us. Dang it.
I get 152.
152. So, it's decreasing from negative infinity to 2, and from 2 to infinity, we're increasing again.
And why is it decreasing and increasing?
Well, Ben, good question. The reason why it's decreasing is because a negative slope, in this case, the first derivative can be thought of as a slope. Since we have a negative slope here, then anywhere between negative infinity and 2, we're going to be decreasing. Okay. So that's the reason why. So the same thing follows for this. Since this is a positive slope, then from the region from 2 to infinity, we'll be increasing in that roller coaster. And so this would be kind of like the value of the roller. I love roller coasters. Yeah. All my analogies revolve around roller coasters and puppies. Puppies. I like puppies.
Okay.
Now, so we're done with the first derivative, almost, except for one thing. We needed to take the second derivative.
Right.
So let's go back and see what our first derivative was.
And this is moving on to part B, right?
And let's use red.
Sure.
The second derivative is going to be, what's 8 times 3?
24.
Yes, thank you. 24 x squared, and that's 64, that's a constant, that goes away. We're just left with that. Now, just like we did before, we need to find critical numbers, but this time these critical numbers are going to be for our second derivative. And that's going to be minus 24x squared equal to 0.
Minus?
Ah, I lied. Yeah, that should be a positive.
Nice save.
Nice save. Thanks, man. So, what do we do here?
Looks like, to solve for x, looks like we need to divide by 24 for both sides.
Yes, first divide both sides by 24. Now, what's the square? What's x squared?
Maybe 0.
Yeah, this is 0. Ben. That's why I have Ben here. he keeps me straight. Let's say this is 0. Alright. And what do we have over here? Negative infinity? Because that's to our left hand side, and this is going to be positive infinity. And let's use orange again. Those are going to be our test points. What should we test? Negative 1 and 1?
Sounds good. Keep it small.
And we're going to plug those tests into our
Second.
first derivative. No, we're not. We're going to plug it into our second derivative.
You tricky.
Yeah. So this is going to be negative 1. We're going to plug that into our what is that going to be? What's 24 times negative 1? So we're going to first square negative 1. That's going to become a positive 1. And that's going to be positive 24. For both cases. So we're going to be concaving from this region, from negative infinity to 0. If I change this to a plus 1, well, that's not going to change much, because if I square 1, I get 1. 1 times 24 is 24 again. So I'm also going to have a positive concavity between 0 and infinity. So in this case, we wouldn't have an inflection point. Because remember, when do we have an inflection point?
We're changing concavity from up to down or down to up.
And in this case, that wouldn't happen. So now, how will we label the intervals? Let's label them in purple. So I would say f of x is decreasing from what range to what range?
Well, looking at our first derivative of the number line, it looks like it's decreasing from negative infinity to positive 2.
Negative infinity to positive 2. And f of x is increasing from
just on the other side, from positive 2 to positive 15.
What about this right here? How would we describe the concavity? So we could say concave up from where to where?
I'd probably say from negative infinity to infinity.
Negative infinity to infinity. And that's it.